Hello everyone. So today we will be seeing shielding effect. Shielding effect in electrostatics, or you can say electrostatic shielding. Electrostatic shielding. So what is this effect? Electrostatic shielding. It is the effect in which a conductor, it is observed only by conductor. A conductor will ensure that the net electric field inside that conductor is zero. So first we will write the definition of shielding effect. So electrostatic shielding is a phenomenon in which an enclosed electric field, enclosed conducting material will protect the interior space from external electric field. You see, very important things are here written. First of all, it is phenomenon observed by only conducting material, and that also what kind of conducting material? Enclosed conducting material. That means you have to have a conducting material which is enclosed like this. It has to be closed from all sides. Okay, let's take this thing. Yeah, here I have, let's say, a shell, a hollow conducting sphere, that is also called shell. Shell means it will have two radius, inner radius and outer radius, and this is made up of conductor. So this is a conductor. So if I have a conductor, then it will protect its inner space. What is this inner space? You see, I am giving them name 1 and 2. So this one, region 1 is basically inner space. So this conducting material, which is a shell here, it will protect its inner space. Inner space means region 1, all this inner space inside, from what? From external electric field, external influence of any charge. So let's say if I have a charge here kept at a space A, let's say I have a positive charge kept at point A, then this point A will have a effect on the inner space of this conducting material, but this conducting material will ensure, what it will ensure? That electric field net inside this shell is equal to 0. That means at all the point, if let's say I mark this point, point P, point Q, point R, everywhere electric field net at P, Q, R, all the space, net electric field will be equal to 0. Now the question comes, how this conductor makes sure that this is happening, that the net electric field inside this conductor or this shell is becoming 0. So the conductor achieves this shielding effect. I will write this. Conductor achieve this shielding effect. Shielding effect means to make sure net electric field inside is 0. So conductor achieve this shielding effect via induced charges. Induced charges. Now let's try to go dig inside how this conductor is making sure that net electric field is becoming 0. So see, here I have a positive charge, which I said. Let's bring it a little bit close. Yeah. This positive charge, what it will do, when a conductor is placed in front of this positive charge, as you know, conductor has a lot of free electrons. Now this positive charge plus Q kept at A will attract those free electrons, because it is positive charge. You know that like charges they repel each other, and unlike charge they attract each other. So many of the free electron will get attracted by this fellow. Let me change the color of the marker. Let's say it's a negative charge, I will draw it with green. So because it's a positive charge, it will attract free electrons on this side. And as you know, our conductor, initially I have not given any charge to the conductor, so the charge initially was neutral overall. That shell was initially neutral. So shell was electrically neutral. Now this shell, if it is electrically neutral, then if I have a negative charge on this side of the shell, the other side of the shell will have positive charge. Let me write it with red color. Other side of the shell will have positive charge. Okay, and if the shell was initially neutral, then finally also the shell will be neutral only, because you know total charge will be conserved on the shell. Q total on shell initial is equal to Q total on shell final. This is basically charge conservation, we have seen already. So if you have some negative charge which is getting induced on the right side of the shell, then on the left side of the shell we will have positive charge. Now let's try to understand how this electric field is becoming zero at point Q. This A charge will have an electric field at point Q in this direction. Let's say I am denoting this with electric field due to plus Q, okay, and in vector form. So this plus Q charge kept at A, point A, will have an electric field in the given direction as I have shown. In this direction electric field will be there because of this plus Q charge. Okay. Now this induced charge, it will induce itself in such a way that it will produce exactly same amount of electric field in opposite direction. Now see, this is the electric field due to induced charge. I am just writing E induced. So if I have an electric field due to plus Q charge, here this plus Q charge is producing an electric field at this point in this direction, then the induced charge will produce electric field of exactly same amount but in opposite direction, and that's how it will cancel each other. They will neutralize each other. Why? Because these electric fields are equal in magnitude but opposite in direction. Not only at that point, see, even at point P, this plus Q will produce electric field in this direction, and this induced charge will produce electric field in opposite direction. At all those points inside this shell, net electric field will be zero. In this way, there will be one electric field due to this plus Q charge which is kept outside, and exactly in opposite direction, induced charge will produce electric field such that E due to plus Q and E due to induced charges will give you a vector sum is equal to 0, for which reason? For inside the shell, for inside region. Everywhere on the inside region you will have net electric field 0, because electric field due to plus Q is getting neutralized by the electric field produced by this induced charges. Okay. Now here comes something more interesting about this shielding effect. Let's pay attention and listen carefully, dear all students. You see, shielding effect works both way. I will explain what I told. Shielding effect works two way. What do you mean shielding effect works two way? You see, we have seen if you keep a charge outside, then inside region net electric field will be 0. Something similar will happen if you put a charge inside. Let's say again I have a shell. You see, we need not to have a shell all the time. We can have a cube, cuboid. It should be hollow cuboid or hollow cube. So outside there should be some conducting material and inside there should be some empty space. So let's say I am taking a shell only, and here I have this conducting material, and inside I have this space, free space. Okay. Now if I keep a charge here Q, then this charge which is kept inside, this charge's effect on outside, here net electric field E net here will also be equal to 0. That means if you keep any charge inside the shell, then the net electric field outside, this region is outside, that will also become 0. So this way I am telling that the shielding effect works both way, two-way process. For outside charge it will protect the inner space, and for inside charge it will protect the outside space. So I will write here electric field outside, or you can say, I will better write it like this way, conductor will not only protect inner space from outside charge or electric field, but also conductor will protect outer space from charge kept inside the conductor. That means electric field not only here, anywhere, even if you give some name, let's say A, here B, here C, everywhere electric field at A, electric field at B, and electric field at C, everywhere electric field will be 0. Which electric field? Net electric field. Net electric field will be 0. Now again question comes, how this conductor is making sure that the net electric field outside is becoming 0? Answer is same, what answer we heard there in the first case. So the answer is same, induced charge. Now we see this charge Q is there. So this charge will ensure that there is a induced charge on the inner surface. So as again this is a positive charge, so on the inner surface there will be negative charge induced, minus charge will be induced on the inner surface, and this minus charge will basically shield the outside space from this inner charge plus Q. This minus charge will make sure that whatever electric field this fellow is producing at A, this negative charge is producing exactly that electric field at A in opposite direction. That means if I give this fellow's name, let's say this is Q induced, here just I am writing Q induced. So electric field due to plus A plus Q plus electric field due to Q induced on which surface? I will write it little bit clearly. Electric field due to plus Q plus electric field due to Q induced on inner surface will make sure that electric field net outside is equal to 0, or I can say will make sure electric field is equal to 0 for outside points. Okay, so for outside points electric field net will be 0, but this is happening only because of, pay attention what I am telling, electric field due to this plus Q charge and the electric field due to Q induced on the inner surface. Now there will be one more induced charge because of charge conservation. As I told, this shell will follow charge conservation. You see, what was the charge on the shell before? Total charge was 0. So if total charge was 0, then if I have an induced charge on the inner surface of this shell, there will be induced charge on the outer surface of the shell also. And how that induced charge will be? If inner surface has negative charge induced, because total charge was 0 before, outer surface will have a charge induced as positive charge. You see, here also this shell will follow what? Charge conservation. So this shell will definitely follow charge conservation. Shell will follow charge conservation. You see, by Gauss law, if you apply Gauss law, if you remember Gauss law will say that if you make a hollow sphere here inside the material of this conducting shell, then Gauss laws will ensure that if electric field everywhere is 0, then the total charge inside will be equal to 0. So that via Gauss law, as we have seen before, this Q induced will have a value as minus Q. And on outside charge, by charge conservation, outside of this shell, if the inner surface has charge as minus Q, then the outer surface will have total charge as plus Q. I write it with red color. This outside shell, outer surface of this outside shell will have a total charge as plus Q, and the inside of this shell will have total charge as minus Q. This is happening because of Gauss law. As per Gauss law, if you make a Gaussian surface like this, you will get total charge inside has to be 0 because electric field here has to be 0. If this is plus Q, this has to be minus Q. Now see, because of these two fellow, plus Q and this minus Q, the induced charge on the inner surface, net electric field outside has to be 0. Okay? But this plus Q will have a electric field here. So you can see this is net electric field due to, you can write it here also, this is due to plus Q and inner surface induced charge. But the outside surface, this charge plus Q induced charge which is present here, this will have definitely electric field at point A. So I will summarize whatever we have seen here. Let's summarize. First point, if we have charge outside, then induced charge will be present, only on the outer surface of the shell. You see, in the previous case, as we had seen, if I have a shell here, and if I put a charge plus Q here, then I will have an induced charge only on the outer surface of the shell. That means here we will have negative charge and this side we will have positive charge. Okay, and this will ensure that the net electric field inside everywhere is what? 0. That we have already seen. Second important point, what we have seen, that if we have a charge inside the shell, then we will have induced charge on both inner and outer surface of the shell like we had seen just now here. If I have a charge here plus q, I will have an induced charge on the inner surface as well as on the outer surface. Okay. Electric field net due to inside charge and inner surface induced charge will have net electric field outside is equal to 0. Which two electric field will be 0? Vector sum will be 0. Electric field due to inside charge. You see inside charge. This is the inside charge here. This is the inside charge which was present. And what I said? Inner surface induced charge. Inner surface induced charge is which? This one, which is minus q. These two fellows will have a net electric field outside is equal to 0. Okay. Here only I should write due to outer surface induced charge there may be electric field outside. Okay, here we saw that because of this induced charge on the outer surface there may be electric field here, but the net effect of that inside charge and inner induced charge, net effect here because of this charge and this charge will be 0. Okay, so this is basically shielding effect, which first we saw shielding effect because of a external charge kept outside. How the shielding effect will work? Here we saw that charge was induced only on the outer surface and the net electric field inside will become 0. But if you put a charge inside, then on both surface there will be induced charge, inner surface and outer surface. These two will have net electric field outside 0 and outside charge may have a net electric field here. So that's it.